Okay, so as we did in the last video, we went over the different topics that we were looking at, the difference between endocrine, exocrine, paracrine, and autocrine. We looked at what the functions of the endocrine system were. We looked at the different endocrine organs that we had in the body. So we had the different endocrine glands, and then these are endocrine tissues that maybe not are specifically endocrine. They're more part of another system, but have endocrine secreting cells in them. Then we looked at this picture. I know this looks confusing here, but we went over the relationship between the hypothalamus and the pituitary. You should know all your 7 anterior pituitary hormones, your 2 posterior pituitary hormones. You should know the target tissue that these hormones are secreted, and then you should know what the target tissue is going to do in response to being stimulated by that hormone. So you just need to practice going over it. Like I would draw it out like we did before. So make sure that you at least memorize what your 7 anterior pituitary and then your 2 posterior pituitary. And then you also memorize the hypothalamic hormones. The hypothalamic hormones are easy because they all have an R in it. They all have an R. Thyrotropin releasing hormone, what's that going to do? It's going to produce the pituitary it's going to stimulate the pituitary to release thyroid stimulating hormone or prolactin. The corticotropin releasing hormone is going to produce the release of ACTH, which is your adrenocorticotropic hormone. That is going to stimulate your adrenal gland to secrete cortisol. Gonadotropin releasing hormone is going to stimulate your pituitary to release either follicle stimulating hormone or luteinizing hormone. The follicle stimulating hormone is going to do the testes and the ovaries. The testes, it's going to make sperm. The ovaries, it's going to make egg. I like to think of follicle as something that grows like a seed, and I think the egg and the sperm are like seeds. The luteinizing hormone is going to make the testes and the ovaries secrete testosterone. Gonadotropin releasing or growth hormone releasing hormone is going to tell the pituitary gland to release growth hormone. What's growth hormone going to do? It's going to tell the liver and the muscles to release IGF-1. IGF-1 then causes growth of tissue. That's how you get bigger. So make sure you know those. And then make sure you understand the negative feedback loop of how this works. The hormone body says, I like what you did, but stop doing it. Oh, hold on a sec. So we did that before where we drew our hypothalamus, our pituitary, and then our gland, our organ. So we had our thyroid, you had your pituitary, and you had your hypothalamus. So what happens is the thyroid secretes T4, right? How does it know? Well, that's because the pituitary tells it by stimulating it with thyroid stimulating hormone. But the pituitary, how does it know to release thyroid stimulating hormone? The hypothalamus has to tell it that. So the hypothalamus is going to tell it to do what? To thyroid releasing or thyrotropin releasing hormone. So you get low T4. That's going to stimulate. Low T4 is the stimulus to tell the hypothalamus to release thyroid releasing hormone. Thyroid releasing hormone is going to stimulate the pituitary to release thyroid stimulating hormone. Thyroid stimulating hormone is an anterior pituitary hormone that's going to tell the thyroid to release thyroid hormone. Then thyroid hormone comes back up and it says, hey, thyroid hormone level is normal. This is the negative feedback loop. Now we need to stop. Boop, boop, boop. Euthyroid. So, what hormone triggers the release of TSH from the anterior pituitary? So, thyroid stimulating hormone. Which tissue produces releasing and inhibiting hormones? Thyrotropin releasing hormones, hypothalamus. Remember, all hypothalamic hormones are going to be releasing or inhibiting. What are the 7 anterior pituitary hormones? TSH, prolactin, ACTH, growth hormone, LH, FSH. You should be able to do it like that. So another topic that we need to review is the difference between hormones, the chemical differences. So some hormones are going to be lipid soluble and some are going to be water soluble. Well, what the heck? Why does it matter so much? Well, you're going to have steroid hormones, thyroid hormones, and nitric oxide are all going to be fat soluble. Water soluble ones are going to be our amine based ones, our peptide ones like insulin, and some of our eicosanoids. So, why is this important to us? Well, what is our blood made out of? Our blood is a connective tissue, right? It's made of mostly water. It's made of mostly water. If you are water soluble, are you going to be able to dissolve in the water in our blood? Yeah, it's telling you yes. So these things can freely float in here. So you can have stuff like insulin, it's going to be good. But if you have a lipid soluble, is it going to want to dissolve in your blood? No, it doesn't want to dissolve in your blood, right? Because water and oil don't mix, water and fats don't mix. So you have to have a transport protein to be able to drive these around so that they can dissolve in the blood. So they're going to have these carriers. Oh, hold on a second. So these hormones can't bind to their target cell unless they are free from the protein or the carrier that's carrying it around. So sometimes when you see tests, you'll see free testosterone or total testosterone. Testosterone is a steroid hormone, like estrogen and corticosteroids. So they need to be transported around by proteins in the blood. If they're all bound up by the proteins, they can't bind to the target cell. Okay, so that's the one difference. Lipid soluble needs transport proteins. Water soluble can just transport around freely. Now, what's the other part of this? Well, those hormones have to go into a cell. So once they pass through the lipid soluble, they get dropped off. Um, they get to the cell membrane. Now, what's the cell membrane made out of? You remember it's made of lipids. So fat soluble ones are going to be able to pass directly through and go to the nucleus and bind to the nuclear receptors to get it to go. So they can dissolve right through it. Water soluble ones, on the other hand, they cannot pass through the lipid membrane. So what do they have to do? They have to bind to a receptor on the outside that's going to then influence the inside of the cell to do it whatever that hormone was telling it to do. So what's the difference? You have water soluble, you have fat soluble. Water soluble, they can be transported in the blood freely, but when they get to the cell membrane, they've got to bind to a receptor on the outside. So they're going to tell the target cell what to do. They're going to communicate. So that receptor is then going to take that signal and whatever that that insulin, it's going to tell it now to start accepting glucose into the cell. If it's like a thyroid hormone, which is a fat soluble one, what's going to happen is it's just going to pass directly through. It's going to bind to the nuclear receptor and it's going to tell that cell to do its job. So if this is like T3, it's going to bind to it and it's going to be like, all right, start doing whatever it is this cell does. So make sure you know the differences between lipid soluble and fat soluble. What else? All right, I think that's it for this chapter as far as kind of important topics go.